Vector subtraction linear. Over a 20-minute period, a car travels along a road with many turns. The car's initial velocity is 60 kilometers an hour, 35 degrees west of north. The car's final velocity is 75 kilometers an hour, 35 degrees west of north. What is the car's average acceleration? Average acceleration in 2D occurs when there is a change in speed, a change in direction, or a change in both. So we shall start off with our givens. We have the time, our v1, and our v2. So time is equal to 20 minutes, or 1200 seconds. Our v1 is equal to 60 kilometers an hour, 35 degrees west of north. And our v2 is equal to 75 kilometers an hour, 35 degrees west of north. What is our average acceleration? These are just some of the equations we might have to use in order to figure out average acceleration. Average acceleration is equal to delta v over t. We might also have to use c squared equals a squared plus b squared, Pythagorean theorem. And we might even have to use average velocity equation, which is equal to delta d over t. So let's begin. We're going to separate our first velocity into two separate vectors. This becomes 60 kilometers an hour sine 35 west plus 60 kilometers an hour cos 35 north, which is equal to 34.4 kilometers an hour west plus 49.15 kilometers north. This is equal to 34.4 kilometers an hour west plus 49.2 kilometers an hour north. Now we're going to do the same thing to our second velocity. This becomes 75 kilometers an hour sine 35 west plus 75 kilometers an hour cos 35 north. This is equal to 37.5 kilometers an hour west plus 61.4 kilometers north. So now we're going to add up our vectors to create our new right-angled triangle. In this case, we're going to subtract our first velocity from our second velocity, starting with our x values. Vx2 minus Vx1 is equal to 37.5 kilometers an hour west minus 34.4 kilometers an hour west, which is equal to 3.1 kilometers an hour west. And we shall do the same thing with our y-axis values. So Vy2 minus Vy1 is equal to 61.4 kilometers an hour north minus 49.2 kilometers an hour, which is equal to 12.2 kilometers an hour north. So our total velocity is equal to 3.1 kilometers an hour west plus 12.2 kilometers north. But since our directions are different, we must use Pythagorean theorem. Because they are at a right angle, it is okay to use it. This becomes 3.1 squared plus 12.2 squared, which equals 9.61 plus 148.84. When you add them up, it becomes 158.45, and we're going to square root it, and it becomes 12.587 kilometers an hour. When you round it, it becomes 12.6 kilometers an hour. So now we want to try and find the angle. The equation for this is tan theta equals Vy over Vx. Theta equals tan inverse of 12.25 over 3.1, which equals 75.79 degrees, but since it's over 45, we're going to subtract it from 90 degrees. Which is equal to 14.2 degrees. And since we subtracted it from 9 degrees, we have to flip the signs, so now it becomes 14.2 degrees north of west instead of west of north. And finally, we use the equation average velocity equals delta velocity over time, which is equal to 12.6 kilometers an hour, 14.2 degrees north of west, over time, which is 20 minutes, but since it is in hours, we must convert 20 minutes into hours. So 20 minutes equals 0.33 hours, and you get this by simply dividing 20 minutes by 60 because there are 60 minutes in 1 hour. So over 0.33 hours, this gives you 31.8 kilometers hours squared, 14.2 degrees north of west.